So, the vector topics what we are learning. Already yesterday I told now. So, vectors is the topic which is related to the physical quantities. We are classifying the different types, and using this we can able to solve the certain problems in easy way. Compared to mathematical approaches, some problems can be done very easily using these techniques. Okay, so for that, starting we can say physical quantities we are classifying into mainly two types. One is called as vectors, second one is called as scalars. So what is the use of this one to classify this one? That we can go with respect to examples. Okay, so we have this is the summer, right? Okay, this is summer. So in summer at different places we have different temperatures. Different places, different temperatures. Yes, sir?
Temperatures.
Right.
Yes,
So
sir.
what is the temperature of the cities means? You can see the only number in the expression, 51 degrees, 41 degrees, 31 degrees, like that. So there will be no direction of it. Anyone says that temperature is towards this direction, temperature is towards west, like that? No, right?
No,
So
sir.
temperature is one of the physical quantity we are expressing only with value. Okay, that is called magnitude, right? So the physical quantities which are only expressing with the magnitudes is called as scalar quantities. Understanding?
Magnitude and direction.
Magnitude and direction is
Vector.
called as vector
Vector
quantities. You
quantity.
know that, right? So example, force. I am applying the force on my hand. What direction? Downward. If you apply the force downward, the body will move downwards. Suppose if I am applying the force from below, the hand will move upwards. So the same physical quantities, according to the direction what happened, the motion of the body also changing. That type of physical quantity is called as vector quantities. So scalar quantities are the quantities which are having only magnitude, no direction. Vector quantities are the quantities which are having both magnitude as well as direction. So I can write here scalars are having only magnitudes. Yes or no?
Yes, sir.
Only magnitudes. But vectors, okay, magnitudes plus direction also. So example for scalar quantities, we have many scalar quantities are there. Most of the cases we are using like temperature, okay, is one of the example for scalar quantity. Work is also one of the scalar quantity, okay, and distance also one of the scalar quantity. Like that we have many types of physical quantities are there in physics which are having only magnitudes. And vector quantities also we have many examples. The examples for vector quantities are, so we can say simply starting from, okay, displacement. Okay, displacement is one of the vector quantity we are indicating with the S arrow, and the velocity is also one of the vector quantity we are indicating with the arrow. And if you come across the case of higher level, torque, TORQE, torque is also one of the vector quantity which is having
What is
direction.
it, sir?
Torque, TORQE, torque.
Yes, sir. What is it?
What is this means? It is one of the force, one type of a force, but this force makes the body to rotate.
Okay.
Understand me? If you apply the force on a body, what happens? The body will move. Look at this one. This is the body we taken. If I am applying the force on this one, what happens? The body will move in a straight line. That is nothing but calling as force. If you are applying the force on the same thing, that means I taken one stone here, tied with a thread. Now I am applying the force on this, okay, spring, stone. What happens? The stone will move like this because it is tied at one. Now this force, whatever it is, making this body to rotate, that is we are calling as torque. Understanding? The rotational force is called as torque. Clear? So this is the
Okay,
way you
sir.
are going
But
to express
what
the quantity.
force?
How we are representing scalar quantity. Scalar quantity is any physical quantity. If you are saying a scalar quantity, that scalar quantities we are representing with a straight line. only with a line. So that means this is the starting point of the scalar quantity. This is the ending point of the scalar quantity. Mute it please. Mute. So scalar quantity we are indicating the straight line with initial point and final point. This is called body of a physical quantity. This length, how much it is, that is called as magnitude. Okay, that body we are called as magnitude. Right? So all scalar quantities we are measuring in terms of magnitude. Example, a person starting from here, he walked through a distance of 10 kilometers. So the 10 kilometers I am taking as a small length. Okay, so I am representing that one S bar. I am writing as a S bar. Okay, S bar I am writing. That is equal to S is nothing but distance, bar nothing but scalar quantity, is equal to how we are representing that we are representing like this. If you want to represent it exactly, you take this one as P. So you consider this point as a P, this point as Q. If you consider P and Q, in this case, distance is scalar quantity S bar. We are calling as bar. So that we are representing as P to Q length. Only magnitude we are measuring. Magnitude means only number. So that means this is the way you are going to represent that one. That is called as mod PQ. Mod PQ. This is the representation of this one. Also we can write in terms of PQ bar. Also we can write. So in this case, what is the distance according to example? Example, distance is equal to 10 is the magnitude. And if you want to represent any units, that units is kilometers. So here, what is 10 here? 10 is called as magnitude. That number you can represent with no need to take 10 kilometers line. So just you take a small 1 centimeter. The corresponding equivalent of 10 kilometers can be taken as 1 centimeter. Like that, we can able to represent any scalar quantity in shorter way. Okay. Next one, vector quantity. How to represent the vectors? Vector is represented with a straight line along with arrow mark.
Arrow.
Okay.
Direction.
So this is called as initial point, and this is called as final point. Arrow mark will be always at final point. Initial point if you represent with a P, final point if you represent with a Q, then this PQ is a vector quantity. If you say, that means you have to keep the arrow mark above it. Now this means that this is the one of the physical quantity which is having magnitude. What is magnitude? From P to Q, length gives the magnitude. That is something but only magnitude means that is mod PQ. And also direction, which gives the direction. This arrow mark gives the direction. Which gives the direction? The arrow mark. That direction is indicated by, for any physical quantity, as a unit vector. As a unit vector, that we are calling as here PQ cap. That I will explain.
Sir, what is this mod?
Yes. So in this case, what is PQ cap means? Unit vector. What is that unit vector? Nothing but it is one type of a vector, because in the vectors we have many classification of vectors are there. After this one, I will explain the types of vectors. Okay. In that, one of the vector is called as unit vector. What is this unit vector? Okay, that is important for us. That's why we are discussing initial one. Unit vector we are representing with like cap.
One magnitude.
We are indicating cap. Suppose if A is the vector, if you say, we are indicating B cap. B is the vector, if you say, B cap, like that. Okay. Unit vector A cap. What is unit vector? This is most important. If you understand this one clearly, almost you can do it most of the problems in the vectors. This is a vector, right? Example, I taken this vector as 10 meters length, right? This vector I am calling as A vector. That is nothing but P to Q length I am calling as A vector. So how to write this A vector? A vector I can write as in terms of mod PQ into, that is A cap. What is this A cap? I said unit vector. What is the meaning of unit vector? Means this 10 meters which is there, I am dividing this into small parts. Exactly equal part, 10 parts you make it. What is the length of the small part? 1. That 1 length, that means the unit length of that part is called as unit vector. That means if you I divide this total vector into 10 parts. How many parts? 10. The 10 parts I am keeping the arrow marks here. The 10 parts I am keeping arrow marks here. 1, 2, 3, 4, like that, so on up to 10. Like this I am taking the 10 arrow marks. So each small vector. This is called small vector. Each small vector, that means if I taken this one, okay, how many times I can take this one? 10 times. The total big vector I taken into 10 parts. The smallest part of that vector which you are calling as unit vector. Okay, what is the meaning of definition of unit vector? Unit vector means this. If you say this is the unit vector that indicating it with a cap, that okay, unit vector having magnitude. This is called magnitude of that one. This magnitude is always 1. How much? 1. The unit vector magnitude always 1. The vector which I taken actually, what is the magnitude? 10. But the smallest part of that vector which I taken called as unit vector, that magnitude is equal to how much? 1. Here what we are understanding is, this is the total length is 10 as per our discussion. The unit vector is how much? 1. So 10 into 1, what it will give? That is nothing but 10. But in this case, we are indicating with cap. What that cap indicates? One is the magnitude. That cap indicates the direction. That means in this case,
Sir, is that
in the case of this
cap
one, I can take it as. Now, I taken a vector along x-axis. Another vector I taken along y-axis. Another vector I taken along z-axis. 3 vectors I take. One is along x-axis, y-axis, z-axis. All I am calling as a vector only. This is a vector A. This is also vector A. This is also vector A. Same vector. But 3 are not same vectors. Okay, that means here, same vector means same type of, they are not the same type of vectors because their directions are not same. 1. Next, how to represent these 3 vectors in terms of unit vector? That is important to understand here. First, if you come across in the case of this one, okay, this vector is along x-axis. If any vector is along x-axis, that vector
Sir,
will be
can you
with
scroll up?
Ax. One vector along x-axis. If that vector is along y-axis, this is along z-axis. If the vector is along x-axis, we are representing with ax. So vector can be written as in terms of the smallest part which you are taking is called as unit vector, that is called as a cap. So what is vector? Vector is nothing but magnitude of the vector, that is mod A. Look at this one. This is magnitude. This magnitude we are representing with mod A into unit vector a cap. Now this a cap, what direction it is? According to coordinates, we know the fixed, okay, x, y, z. If you know exactly x axis, y axis, or z axis, if you know, in that case I can write as mod A into, if it is along x axis exactly, then I can represent it with I cap. I is one of the unit vector. Next one, if that vector is along y axis, in this case, that vector we can write as mod A into a cap. But in this case, that is mod A into what is a cap? That is nothing but we are indicating with j cap, not with I. Similarly, if the vector is along z axis, in that case, mod A into a cap, that a cap can be replaced with mod A into k cap. This is the way you are going to represent the vector in terms of x, y, z axis. That means if the vector is along x axis, mod A into I cap. If the vector is along y axis, mod A into j cap. If the vector is along z axis, mod A into k cap. This represents the vector. Now consider the coordinate system. According to geometry, we have a coordinate system. X axis, y axis, z axis. One person walking towards x axis from the origin. This is the origin. Okay, that vector I am calling as A. Another person walking towards y axis. That person I am calling as B. Otherwise, you can take it as same person. You can take it better. Okay, same person you can take it. And A. If the same person walking towards Z, then how to write the vector? In this case, the vector A. That means if you want to write a vector A is equal to
J.
If A is the vector along x-axis, I can write as per the formula mod A into A cap. But in this case, if A cap is along x-axis, then we are indicating that unit vector as I cap. Suppose the vector is along y-axis, same. Then in this case, A is the magnitude. That means A is the, okay, mod A is the magnitude. Then which gives the direction? J cap gives the direction of that unit vector. If vector is along z-axis, in this case, mod A is the magnitude, but which gives the direction? This k cap gives the direction. If you look at the diagram in the coordinate system, I, j, k gives the directions of the unit vector. That gives the total vector direction actually. Okay, this is the way you are going to represent the one dimension. So I can classify the vectors according to the way they are oriented. One is called one dimension vector, two dimensional vector, three dimension vector. If you're able to write how to write one dimension, two dimension, three dimension, that's over. Then after we can go for a little bit next level of understanding. So how to write one dimension vector? One dimension vector is nothing but if A is the vector, it is only along x-axis, then I am writing as one dimension vector as Ax vector. Ax vector is equal to mod A into I cap. Similarly, if the same vector is along y-axis, only along y-axis, that is also called as one dimension vector, that we are representing with mod A into j cap. The same vector is only along z-axis, that is also we are representing with mod A into k cap. So this is called one dimension vector representation. This is 1, 1, 1. Next, two dimension vector. How to represent the two dimension vector? If A is the vector, if you say, if you want to express this one, you have to express the two dimension vector with x comma y. Like this, you have to express A of x comma y. This is called two dimension vector. Now this is the combination of two directions vector. Combination of two directions. That means if you take in the coordinate system here, this is the way the vector. Okay, suppose the ant is here. The ant is here, not on the x-axis, not on the y-axis. It is in between x and y. In this case, I want to represent the position of the that ant using a vector by taking the straight line and using arrow mark. This vector is called as two-dimension vector, which is in between the x and y. So how to write this one? This vector we can write in terms of ax vector comma ay vector. This is called representation of two-dimension vector. If you want to write it more closely, okay, so that means it is not the enough. So we have to express it more, okay, precisely. What way? A comma a of x comma y is equal to, that is nothing but ax vector plus ay vector. Both combination, it is a vector. If only one dimension, we have only ax, only y-axis ay, only z-axis az. But if it is a combination of x and y, ax plus ay. Similarly, that same vector is in between y comma z axis, in between y axis and z axis. In this case, ay vector plus az vector at y. If suppose that the same vector is in between x and z, in that case, ax vector plus az vector. Like this, you have to go to represent the two-dimension vector. One dimension, two dimension vectors can be represented as you're looking like this. If the vector is present between x comma y, in this case I am representing this one as ax vector plus ay vector. That ax vector I can write as a into I cap plus, that is a into j cap. This is we are indicating with a bar. Like this also we can. If a vector is between y and z axis, in this case the vector is between ay vector plus az vector. This also I can write in terms of magnitude and direction using in terms of unit vector as a bar. I means what is unit vector along y axis? J cap plus a bar in the z axis means what is unit vector along z axis? K cap. Like this we have to. Suppose if the same vector is along, okay, x axis and z axis. In this case we can write as ax vector plus az vector. That is equal to, we can write as in terms of mod a into x means what is the unit vector? I cap plus az. Az means magnitude to, okay, what is z? K cap. This is the way you are going to represent the which one? vectors along two-dimension direction. Last one, three-dimension vector. What is three-dimension vector? In the space we have Earth. Where is the Earth in the space means using coordinate system you can able to express the position of the Earth. In the space, the Earth is somewhere here. It is lies between x, y, z. It is not along the x, y. It is not along y, z. It is not along x and z. Like housefly is flying here. In the air, in between the room. So what is the position of that one? That is three dimension. It is lies between x-axis also, y also, z also. In that case, to identify the position of that one, if you are indicating the vector as A, the three-dimension vector, if it is called, then that vector, which lies between x, y, z, can be represented as in terms of ax vector plus ay vector plus az vector, three directions. So each direction vector you have added three times. This we can write it exactly in terms of unit vector as mod A into I cap plus mod A into j cap plus mod A into k cap. So this is the way you are going to represent the three-dimension vector, similar to two-dimension. Any doubt? Magnitude. How to find the magnitude of the vector? Either one dimension, two dimension, three dimension. Suppose if A is the vector only along x-axis. If A is the vector along only x-axis, that vector we can write as mod A into I cap. Already I told. So in this case, what is magnitude? This A is called as magnitude. That means mod A is called as magnitude. Similarly, if AY is the vector, what is the magnitude? In that case, mod A into j cap. In this case, what is magnitude? Mod A. If AZ is the vector, in this case, that is mod A into k cap is the vector. But what is the magnitude? Mod A. So, if one dimension vector if you taken, if A is the vector along x-axis, only x-axis, only y-axis, only z-axis, what is the magnitude? Mod A, mod A, mod A. But in the case of two-dimension vector, what is two-dimension vector? If A is the vector which is two-dimension x comma y, this we can write in terms of ax vector plus ay vector, just we've written. This also we can write in terms of a vector, mod A into I cap plus mod A into j cap. This is the in terms of x comma y. So how to represent the magnitude of this mod A? Mod A x comma y. How to represent this magnitude? How to represent this two-dimension vector magnitude? To find this one, using geometry, we are going to do that. Two-dimension vector means you know that if you take on the coordinate system here, this is x-axis, this is y-axis, this is origin, right? There is a vector. So this is the point insect in between x and y. So that insect position I am indicating with the two-dimension vector as a of x comma y. Now this a of x comma y, what I've written, first step ax plus ay. What is ax? This is the direction. Along this direction is called as ax. What is ay? This is the direction is called as ay. This is the two-dimension vector. I am indicating with red. This is the two-dimension vector our requirement. That vector I have written as ax plus ay. What is ax? This is ax along x-axis only. What is ay? This is ay. Along x-axis, what is unit vector? I cap. Along y-axis, what is unit vector? J cap. But our requirement is a x comma z. This magnitude I want. That means from here to here, this length I want. Yes or no? I don't want this along x length. I don't want this along y length. I want along x and y combination length. That is called two-dimension vector magnitude. To get this length, what I am doing, I am taking the geometry support. How I am taking the geometry support? Look at this one. This is the vectors I am taking here. This is the two-dimension vector I have taken. This is called as a of x comma y vector, two-dimension vector. Now what you do is, this vector, you take foot of perpendicular here. Geometrically, from the head, you take a foot of perpendicular onto x-axis, where it is coinciding. Okay, that length, that means from the origin, this length gives x value in terms of magnitude, geometrically. Now you take one more from the head, you take one more line onto the, which one? Okay, onto the y-axis. Onto y-axis, one more line you take. Now this line represents, that means from here to here, this represents the ay value. Clear? So this is the vector A, two-dimension vector. This is the two-dimension vector. This two-dimension vector is, we are representing with a comma, a of x comma y. That length along x-axis, this is. This length along y-axis is this is. So using geometry, look at this one, this geometry. We are getting one triangle here. One right angle triangle here. Using the Pythagoras theorem, I can solve it. To use the Pythagoras theorem, I am indicating this as O, this one as A, this one as B. From the triangle OAB, I can able to solve it. From the triangle OAB, I can able to solve it. How to solve it? Using triangle OAB, apply the Pythagoras theorem. If you apply the Pythagoras theorem to this OAB, what you are going to get? OA square is equal to, that is nothing but AB square plus OB square, or OB square plus AB square. AB square plus OB square, or OB square plus AB square. Now what is OA? OA is the length from here to here. This is called, okay, that is A of x comma y. That length we are need to calculate is equal to, length means only magnitude, no direction here. That's why we are not using an IJ case. And what is AB? This is A to B, this length. How to write that length? That length you take it as AX. So this total length OB I am taking as AX, that's why AX square plus OB. What is the length of this one? Okay, this is AY, this is AB, this AB is parallel to this. This is AB, this is exactly parallel to this. I'm indicating with the arrow mark. This is AB, that is exactly parallel to this. So both are same. So that means in the place of AB, I can take it as AY. So that is nothing but AY square. So AXY whole square is equal to x square plus AY square means, what is AXY? AX comma y is equal to under root of AX square plus AY square using Pythagoras theorem. So what is the magnitude of the two-dimension vector? A of x comma y is called as two-dimension vector, whose magnitude is under root of AX square plus AY square. One-dimension vector magnitude is mod A. Two-dimension vector magnitude is under root of, that is AX square plus AY square is the two-dimension vector magnitude. This is the way you are going to represent the two-dimension magnitude.